Hello viewers, welcome to my channel and thank you for watching the videos. In this video I would like to discuss question number 5A of Mathematics Optional Paper 1 UPSC 1992. This question is of complex analysis and question is, if u is equal to e to the power minus x sin y minus y cos y, find v such that fz is equal to u plus iv is analytic. Also find fz explicitly as a function of z. So first we will just see that the property of fz, which is analytic, and then we will use here u we know e to the power minus x sin y minus cos y to find the and fz. This is analytic, then u is constant, which is this one, and v also constant. These two represents families of curves which are orthogonal to each other, means at 90 degree to each other. These curves, family of curves, so many curves are there in u as well as many curves are there in v, because constant. So if we change the coefficient of constant, the value means u is equal to 1 is a constant, u is equal to 10 is a constant. So we may change the value of constant, so we get family of curves. So they are at 90 degree to each other, and by Cauchy's Riemann equation we can write this expression, because we know del u upon del x is equal to del u upon del y, and here we are talking about property that they are at 90 degree. So we can write that product is equal to minus 1, because we know del u upon del x is equal to del u upon del y. So first term gives us minus 1 here, and we know del v upon del x is equal to minus del v upon del y. So this gives plus 1 and product is minus 1. That is, tangents to the curve u is equal to c and v is equal to c dash respectively cut each other at right angles. Thus we have to find out v. When examination you are writing the examination, you need not to explain this much. You may reach to directly at the method, which is now we will use Milne Thompson's method to calculate v, that is the conjugate function of u. And Milne Thompson's method has 4 type of cases. First, when u is given; second, when v is given and we are going to find out function u plus iv; when third, u minus v is given; fourth, u plus v is given. So let's see what is the procedure when u is given. This we know z is equal to x plus y, z bar is x minus iy, x is equal to half of z plus z bar. When we add first two equations we get this y, after subtracting we get y, and 1 upon 2i z minus z bar. So when we put in fz, which is u xy plus iv xy, we put value of x 1 by 2 z plus z bar, and v is 1 upon 2i z minus z bar plus iv. Here v will be there, and then v is also function of this x and y. Now we see, now fz we know Thompson's method plus iv. When we differentiate it we get f dash z, that is del u upon del x plus I del v upon del x. But we have only function u, so we replace del v upon del x as minus del u upon del y. So this becomes f dash z is equal to del u upon del x, and in place of x, this is function of xy. In place of x we write z plus z bar upon 2 and z minus z bar upon 2i, and minus I del u upon del y, and in place of xy we have replaced. This becomes an identity. Now we have been given function u, which is e to the power minus x sin y minus y cos y. We differentiate it with respect to x partially, so it becomes e to the, because e to the power minus x is first function and x sin y minus y cos y is second function, product of two functions. So e to the power minus x sin y minus e to the power minus x sin y minus y cos y. You can differentiate it, and when we differentiate it with respect to y, it becomes e to the power minus x cos y minus cos y plus sin y. So we got this term. These two terms have been written here. So this much is del u upon del x, and this is del u upon del y. Correct. Now we put z is equal to z bar. Now we are using Milne Thompson's method, and it gives x is equal to z and y is equal to 0. When we put x is equal to z and y is equal to 0 in this expression, it reduces to this. You can write sin y is 0 and cos y is 1. Just put x is equal to z and y is equal to 0. Once you did that, you got this function f dash z. Integrate it. Integration is this minus I integration of this. So this becomes e to the power minus z into z minus e to the power z dz. So you can, I think, product of two functions integration you can do and get this value. So do this integration. Now once you got this fz, which is equal to u plus iv, so u plus iv is equal to fz is equal to I, z is x plus iy. In this I am keeping values into e to the power minus x, and minus iy will be there, which is equal to cos y minus I sin y. So this is equal to e to the power minus iy. And now we got terms which no imaginary, it is having no imaginary. Here this is imaginary part. So v is equal to the imaginary part e to the power minus x cos y plus y sin y. So this is the answer. V is this and fz is this one. We have got it.